Hi everyone, in today's presentation we will be covering chapter 4.3, Multiply and Divide Mixed Numbers and Complex Fractions from the OpenStax Pre-Algebra textbook. Our core learning objectives in this video then will be to multiply and divide mixed fractions, 2, simplify complex fractions, and 3, simplify expressions written with a fraction bar. So let's go ahead and start with this initial introduction question then. How do you change a mixed fraction to an improper fraction? First question. And then how would you solve the following problem here, the image that you see in which you are taking one fraction and multiplying by another fraction. So go ahead and pause the video and think about these two questions before we get started. Okay, so first off, looking at how do you change a mixed fraction to an improper fraction, first core thing to remember is this is actually an equivalent way of showing the same type of fraction, right? Going from a mixed to an improper. So for example, let's say you have the mixed fraction 5 and 2/3. So this is a mixed fraction that could be changed to some sort of improper fraction. Now, how do we do this? Well, I'm going to go ahead and draw this out a little bit bigger and then show the mechanics behind this. So our first step here that we want to do is we want to figure out, okay, if I was to take the whole number and basically divide those 5 wholes into a bunch of divisions, what would I need to do that? Well, the operation is multiplying that whole number 5 by the number 3. This basically gives you, if I was to take those 5 wholes, so think 5 whole pizzas or something, and I was to put in each of those 5 whole pizzas, those 3 slices, well, then I would have 15 total slices after that, right? That's 5 times 3. That's that first operation. The second operation then is to take that and add it to our numerator. So this gives the 2 additional pieces after that. Okay, so in other words, you're going to have 17 total pieces that you actually have. That's the numerator. And then in the denominator, you keep your same denominator essentially. So the 3 was the denominator at the beginning, so 3 stays the denominator at the end. Okay, so this is our conversion then between mixed fraction to an improper fraction. Then in the bottom question we have here is how would you solve the following problem, which we have 2 wholes and a half times 3/4 of a fraction. So if I was to rewrite this, this fraction looks like the following. 2 and a half times 3/4. Okay, so how do we actually solve this one? Well, one of the core steps is what we just did up here actually, is to change the mixed fraction part to an improper fraction. So that's what we do to start, is we multiply 2 times 2, which is 4, and then we add that to our numerator, which is 1. So 2 times 2 is 4, 4 plus 1 is 5, over the denominator of 2. So now I have 5/2 times 3/4. And now we follow the steps for multiplying regular fractions, proper fractions or improper fractions that we learned in a previous video. Now, our first step to see that I recommend is to see if we can simplify by cross-reducing to start, meaning can I look diagonally from 5 and 4 and from 2 and 3 to see if I can reduce. In this case, there is not a step or a number we can reduce in these fractions, so then we just go straight to multiplying our numerators, 5 times 3, which is 15, and 2 times 4, which is 8. We then ask, can we simplify this? Well, there's not a number that divides evenly into 15 or 8, right? If I was to rewrite 15 as the factors, its prime factors, 15 would be written as 3 times 5 as prime factors, and 8 would be written as 2 times 2 times 2 as prime factors, or 2 times 4 if you didn't want to do prime factors, just regular factors. And you realize that none of these are common, right? So since none of these are common, I can't actually reduce or simplify by any of these numbers. So what I can do though is I can change this improper fraction, 15 over 8, into a mixed fraction. To do this, we can divide the denominator 8 into our numerator 15. So 8 goes into 15 one time. 1 times 8 is 8. 15 minus 8 is 7. 7 becomes our new numerator, and 8 stays our denominator. So in other words, 15 over 8 converts and changes to 1 7/8 here. Okay, let's go ahead and do a few more multiplying a mixed fraction type problems, now with the specific steps that I'm going to recommend we use. So starting with question number 1 here, we have 1 1/4, that's a mixed fraction, times another mixed fraction, 2 1/2. Now, our first step here is we are going to convert the mixed fractions to improper fractions, which again is to multiply our whole number by the denominator and then add that to the numerator. So 1 times 4 is 4. 4 plus 1 is 5. That is the new numerator, and our denominator stays the same. So 1 1/4 changes to 5/4 times, again, 2 times 2, which is 4, and 4 plus 1, which again is 5. In this case, I have a denominator of 2 though. Okay, so I have 5 over 2. So that's step number 1 for us. Step number 2 is to then simplify by cross-reducing. That's my recommended step. In this case, 5 and 2 and 5 and 4 does not have a common factor, so we cannot simplify by cross-reducing. So I'll check that step off that we've at least looked at it. Step 3, we are now going to multiply our numerator. So 5 times 5 is 25. And then multiply our denominators, 4 times 2, which is 8. Then we look to see if we can simplify. Well, the factors of 25, if I was to do prime factorization of 25, that's 5 times 5. And of 8 is 2 times 2 times 2, right? 2 times 2 is 4, 4 times 2 is 8. None of these are common factors, so I cannot simplify any of these down. So in other words, 25 over 8 is as simplified as you can go. However, we can change this to a mixed fraction. So I can do 8 into 25 here. 8 goes into 25, 8, 16, 24, goes in 3 times. 3 times 8 is 24. 25 minus 24 is 1. 1 is now the remainder. That becomes the new numerator. And our denominator stays the same denominator. So 3 1/8 here. So our answer in mixed fraction form is 3 1/8. And in proper fraction form, it's 25 over 8. Okay, so let's go ahead and look at question number 2 now. So question number 2 is 3 1/4 times 3 1/3. So my first step here is I'm going to convert the mixed fraction to an improper fraction. We're going to do that by multiplying our whole number by the denominator and add that to our numerator. 3 times 4 is 12. 12 plus 1 is 13. Our denominator then stays the number 4. Times 3 times 3 is 9. 9 plus 1 is 10. So 3 1/3 changes to 10 over 3. Then I look to see if I can cross-reduce. In this case, there is a common factor that I can divide into each of these numbers. So 4 and 10 has a common factor of 2 that can divide into both, right? 13 and 3 do not, though. So rewriting this, I now have 13 over 2 times 5 over 3. Okay. So 13 times 5 is going to be 65. 2 times 3 is 6. So 65 over 6 now is my improper fraction. After doing all these steps, forgot to check them off. I cannot simplify. There's not a number that divides into 65 and 6. I actually already simplified in this step. So the only thing I can do is change to a mixed fraction by dividing 6 into 65. So 6 goes into 65 10 times. 10 times 6 is 60. 65 minus 60 is 5. 5 is the remainder. That becomes the new numerator. And 6 stays my denominator. So I have 10 and 5, 6 here as my result for question number 2. Question number 3 is interesting. It adds a negative symbol into this. So it's a positive by a negative. So positive by a negative is going to give us a negative as our final sign, right? So just remember that at the end. Otherwise, the negative doesn't really have much bearing on the problem. So 5 and 2/5 times 1 and 3/7. So I'm going to change to a improper fraction, convert mixed fraction to improper fraction. And I can do that by multiplying 5 times 5 and then adding the 2. 5 times 5 is 25. 25 plus 2 is 27 over the original denominator 5 times our negative. 1 times 7 is 7. 7 plus 3 is 10. 7's our original denominator, stays our denominator. Okay, so next we're going to simplify by cross-reducing. So I can divide a 5 into here and a 5 into here. 27 and 7 do not have a common factor, so I can't simplify that down at all. But I can rewrite this now as 27 over 1 times a negative. 10 divided by 5 is 2 over a 7 here. Okay, so that's simplified by cross-reducing. Next, we can multiply our numerators. So 27 times 2 is 54. And 1 times 7 is 7. And positive by a negative gives me a negative. So I have 54 over 7 now. Well, 54 and 7 does not have a common factor. The only factors of 7 are 7, right? It's a prime number. And since 7 does not go into 54, we can't simplify any further. What I can do, though, is I can change to a mixed fraction. So I ask myself, okay, how many times does 7 go into 54? It goes 7 times. 7 times 7 is 49. 54 minus 49 is 5. 5 is a remainder. It becomes the new numerator of my fraction. 7 is my denominator. So my new answer then in mixed fraction form becomes -7 and 5/7. And that's my result. Okay, so that's multiplying of mixed fractions. Let's go ahead and take a look at dividing mixed fractions now. Now we're going to take a look at dividing mixed fractions, starting with question number 1. 1 2/3 divided by 2 1/4 here. So our first step is the same as with multiplying of mixed fractions in that we are going to change each of these fractions to an improper fraction to start. So to do that, we're going to multiply 1 times 3, which is 3, and then we add that to 2, which is 5. So our improper fraction then becomes 5 over 3. In other words, we have 5 total pieces, and each of the wholes had been divided into thirds. Then the division sign, and then we change 2 1/4. So I multiply 2 times 4, and then add that to 1. 2 times 4 is 8, plus the 1 is 9. So we get 9 over 4 for that fraction. Next, we're going to follow the same steps we learned when dividing of proper or improper fractions. So step 2 is kind of a shorthand way of noting it, but this is the keep it, change it, flip it, or find the reciprocal rule. So what this means is we keep the left side fraction, 5 over 3, that stays the same. We change the division sign to multiplication, and we flip 9 over 4 to become 4 over 9. Now we are just multiplying by another fraction. So dividing by one fraction is the same as multiplying by its reciprocal. Next, we're going to simplify by cross-reducing. So I'm going to look diagonally. 5 and 9 and 3 and 4 do not have any common factors to reduce by. So next, I multiply. 5 times 4 is 20. And then step 5, multiply our denominators. 3 times 9 is 27. So now I have 20 over 27. These cannot be simplified. To show this out, if I was to factor 20 into its prime factors, this would be 2 times 2, which is 4, times 5, which is 20, over 27, which is 3 times 9, or if I was to do all prime factors, it would be 3 times 3, which is 9, times another 3, which is 27. Notice that none of these are common factors, so nothing can be simplified here. Now, 20 over 27 is also a proper fraction, which basically means that this is as much as we can do. So our answer is 20 over 27. So let's now try question number 2, which is dividing a negative 4.5 divided by a negative 2 1/6. Now the negatives, the only bearing the negative has is that we have to remember the negative integer rules or negative number rules for multiplying or dividing, which says when you divide or multiply by 2 negatives, you get a positive result. So our answer in this case is a positive at the end. Okay, so next from there, we can follow our steps. So we're going to convert 4.5 to an improper fraction. I'm going to multiply 4 times 2 and then add that to 1. So 4 times 2 is 8, plus the 1 is 9, over the 2. Division sign, 2 times 6 is 12, plus the 1 is 13. So we get 13 over 6 here. From here, I can follow my keep it, change it, flip it rule, where I keep the 9 over 2 the same. I change the division to multiplication, and I flip 13 over 6 to become 6 over 13. From here, I'm going to simplify by cross-reducing. Well, in this case, I can't simplify 9 and 13. There's not a common factor, but I can simplify 2 and 6. 2 is a common factor for both. So 2 divided by 2 and 6 divided by 2. From here, I can rewrite this as 9 over 1 times 3 over 13. Now I can multiply my numerators. 9 times 3 is 27. Multiply my denominators. 1 times 13 is 13. Now 27 over 13 does not have a common factor to simplify by. 13 is a prime number, and since 13 does not go into 27, it can't be simplified. However, it can be changed to a mixed fraction. So to illustrate this, we can use long division. 13 goes on the outside of a long division bar. 13 goes into 27 2 times, right? 13 times 1 is 13. 13 times 2 is 26. 2 times 13 is 26, so 27 minus 26 is 1. 1 is now my remainder. My denominator stays the original denominator of 13. So my answer in mixed fraction form is 2 and 1/13. Let's take a look at the final question now, which is going to be 5 2/3 divided by 3 1/4. So again, our initial step is the same in that we're changing our mixed fractions to improper fractions here. So we are going to multiply 5 times 3, which is 15, and add that to 2, which is 17. So our first fraction changes to 17 over 3, division sign, and then we have 3 times 4, which is 12, plus 1, which is 13. So we have 13 over 4 here. Next, we are going to do the keep it, change it, flip it rule. So 17 over 3 stays the same. Division changes to multiplication. And 13 over 4, we find the reciprocal of that, which is now 4 over 13. From here, we can see if we can cross-reduce. There is not a number that divides evenly into 3 and 4, nor is there a number that divides into 13 and 17. So we can't cross-reduce. We then go ahead and see if we can multiply. So we go ahead and multiply. We know we can multiply. So let's go ahead and do 17 times 4 and 3 times 13. So 17 times 4 then is 68. And 3 times 13 is going to be 39. Now 68 and 39 can't be reduced down. 39 is a prime number, and there's no number that 39 does not divide into 68. So then what we can do is we can change to a mixed fraction. By the way, I want to amend my previous statement here. 39 is actually not a prime number. The factors of 39 that divide into 39 are 3 and 13. 3 and 13 are prime numbers, but neither do 3 and 13 actually divide into 68. So it still does not simplify down, but I was incorrect in noting that 39 was a prime number. It's not. So 68 over 39 cannot be simplified, but we can change it to a mixed fraction. I'm going to do 39 into 68 now. 39 goes into 68 one time. One times 39 is 39. And 68 minus 39 is 29. 29 is now my numerator, and my denominator stays 39. So 68 over 39 as an improper fraction converts to a mixed fraction of 1 and 29 over 39. Our next series of questions are now complex fractions, where we have two fractions that are being divided by each other. So usually this is shown by a long division bar, or excuse me, a long fraction bar, I should say. And then what we have on top and bottom is a fraction and another fraction. So in this case, these are not actually really extending the bar out. So many times when it's being transcribed down, it doesn't have that long of a bar. But I like to then go and make sure that we can see specifically, hey, there's a fraction on top and a fraction on bottom now. So step number one, instead of showing this vertically, it is easier to then show horizontally. So if we were to write this out horizontally, this would be 1/3 divided by 1/7. So now we can follow the steps we were learning previously, where we have proper fractions, in this case, being divided by each other. So from here, we can do the keep it, change it, flip it rule. So 1/3 stays 1/3. Division, division changes to multiplication, and 1/7 becomes 7/1. Next, we can simplify by cross-reducing. In this case, 1 and 1 and 3 and 7 cannot be reduced down. So then we go to multiplying our numerators. 1 times 7 is 7, and multiplying our denominators, 3 times 1 is 3. So we now have 7/3 here. 7/3 cannot be simplified down. However, it can be changed to a mixed fraction. So 3 divides into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. 1 is now my new numerator, and 3 stays my denominator. So 7 1/3 converts to 2 1/3. The next complex fraction we will look at is question number 2, which is 1/4 on the top part of the complex fraction. Then we have that long division bar, and then 2/5 on the bottom part. So our first step here is we're going to show the fractions now horizontally. So I have 1/4 divided by 2/5. Next, I'm going to do the keep it, change it, flip it rule. So 1/4 stays 1/4. Division changes to multiplication, and 2/5 changes to 5/2. Next, we can simplify by cross-reducing. Well, in this case, 4 and 5 and 1 and 2 cannot be simplified down. So I just go to step 4, multiply my numerators. 1 times 5 is 5. And multiply my denominators. 4 times 2, which is 8. So we now have 5/8. This is a proper fraction. Proper fractions can't be changed to mixed fractions. We then look to see if we can simplify it. Well, 5 and 8 does not have a common factor. So that's as far as we can go. 5/8 is our result. Question number 3, the final question then, is 5/6 long division bar 4. So this is a complex fraction written vertically again. In this case, we have a fraction by a whole number. So when we do step number 1, show our fractions horizontally, we have 5/6 that's on the left divided by a whole number 4 here. Now, when we have a whole number, we can structure that as a fraction by putting a 1 in the denominator here. So now we have two fractions. Let's go ahead and follow the keep it, change it, flip it rule, where we keep 5/6 the same. We change the division to multiplication, and then we flip or find the reciprocal of 4/1, which is 1/4. From here, we can simplify by cross-reducing. Again, in this case, 5 and 4 and 1 and 6 cannot be reduced down, but we can multiply our numerators at this point. So let's multiply our numerators. 5 times 1 is 5. 6 times 4 is 24. And we now have 5/24. Well, 5/24 cannot be simplified down, right? If I looked at the factors of 5, that would just be 1 times 5. 5 is a prime number. Over, for 24, it would be 2 times 2 is 4, times 2 is 8, times 3 is 24. Well, you can see that none of these have common factors here, so because of that, I can't simplify this down. This is a proper fraction, so it's going to stay a proper fraction, can't be converted. So 5 over 24 is our result. The next series of questions deal with simplifying expressions with a fraction bar here. So what we're going to do first in this case is we're going to do 12 plus 6, which is in the numerator, and 5 minus 2, which is in the denominator. So 12 plus 6 is equal to 18, and 5 minus 2 is equal to 3. So we now have the fraction 18 over 3, which you might notice 3 goes into 18, so in reality, you're just dividing both the top and the bottom by 3. Now, if you wanted to show in more kind of fraction-y terms, you can divide the numerator by 3 and the denominator by 3. And what you get in terms of an equivalent fraction is really 6 over 1, which just divides down to 6. Now, you could recognize again that this is just a whole number 18 divided by another whole number 3, essentially. So 6 is your result. Looking at question 2 now, we have 8 squared minus 5 squared, and then 5 minus 8 in the denominator. So let's do the numerator part first, where we need to do the squares. So 8 squared is 64, minus 5 squared, which is 25. So now I have 64 minus 25 on top, and 5 minus 8 on the bottom. So 64 minus 25 then is equal to 39, and 5 minus 8 is equal to negative 3. So 39 divided by negative 3, you now have a positive by a negative, so you know you're going to get a negative result. 39 divided by 3 then, 3 divides evenly into 39, so again, really, you could just divide it, or you could show it kind of in a more equivalent fraction format, where we now get 13 over 1, and 13 over 1 just becomes 13. And again, positive by a negative, so you get a negative result here. The final question, question 3, we have 9 plus 4 times 3 in the numerator, and negative 5 minus positive 2 squared. So if we do what's in the numerator first, we have 9 plus 4 times 3, so 4 times 3 is 12. So I have 9 plus 12. And then if I do in the denominator, we're going to do the square part first, which is 2 times 2, which is 4. So we get negative 5 minus 4. I'll go ahead and rewrite this down here. So 9 plus 12 over negative 5 minus 4. 9 plus 12 then is equal to positive 21. And negative 5 minus 4 is equal to negative 9. So now at this point, 9 does not go into negative 21 or positive 21, but what does go into both is 3. So you can actually divide both the top and the bottom parts of this fraction by 3. So divide by 3, divide by 3, and the equivalent fraction form that you get here is 21 divided by 3 is 7. Negative 9 divided by 3 is negative 3 here. So you have 7 divided by negative 3, so you could just rewrite this as negative 7 over 3 now, which you can change to a mixed fraction. 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. 1 is now your numerator, and 3 stays your denominator. Again, this was negative by a positive, so you get a negative result here. So -2 1/3 is the mixed fraction form. The final two questions are some mixed fraction word problems in which we're trying to identify the type of operation we're using to solve for a contextual type problem. So we have a baker uses 2/4 of a cup of flour for each batch of bread. How many cups of flour then are needed to make 3.5 batches? Okay, so essentially, if I was to kind of think about it and draw it out a little bit, um, we have 3.5 batches. So essentially, if we say, okay, batch one, so this is batch number one, say B1, and then we have B2, and then we have B3, and then we have half a batch basically at the end. So this kind of is almost batch number 4, but we'll say kind of it's a half of a batch essentially. Now on each of these, then we have 2 1/4 cups, 2 1/4 cups, 2 1/4 cups, and then basically we have 2 1/4 cups divided by 2 in a sense. In other words, half of that. Okay, so what you then see here is we're combining all these together essentially. So you could kind of think of this in terms of addition, right? So all of these are being added together in a sense. But remember what repeated addition happens to be. What is repeated addition? Well, that's simply multiplication. So in reality, the easiest operation that you could do to solve this is you can take the amount of flour that you have per batch, so 2 1/4 represents one batch, and since you're doing 3.5 batches, you can multiply this by 3.5, right? So then we can follow the steps that we were learning previously from multiplying mixed fractions, in which we're first going to change these to improper fractions. So I can do 2 times 4, which is 8, plus the 1, which is 9, over the denominator 4, times 3.5, so I can do 3 times 2, which is 6, plus the 1, which is 7. So I get 7 over 2 here. So now I have 9/4 times 7 over 2. I first look to see if I can cross reduce, which I can't. So then I multiply. 9 times 7 then is 63. And 4 times 2 is 8. So now I have 63 over 8. Now, there's not a number that divides evenly into 63 and 8, but there is a mixed fraction that can come out of this. So we're now going to ask, how many times does 8 go into 63? So 8 goes into 63 7 times. 7 times 8 is 56. And then we're going to do 63 minus 56, which is equal to 7. And then we keep the same denominator, which is 8. So in other words, what this is basically telling us is that we need 7 7/8 cup of flour to make 3.5 batches of bread here. So that's question 1. Question 2 then, a board is 12.5 feet long. So if I kind of draw this out again, this board, is 12.5 feet long in total. Then we're making some shelves. So each shelf requires 2.5 feet of wood. How many shelves can be cut from the board? So in other words, we're basically breaking this into smaller chunks. So let's say this piece then can make a shelf, that's 2.5. This piece can make a shelf, 2.5, so on and so forth. So we're dividing it, right? We're making these into smaller groupings out of 12.5. So if I wrote this as an operation, we are going to take the 12.5 and we're going to divide it by the smaller grouping of 2.5. Okay. So then we follow our steps to divide mixed fractions. Our first step again, like multiplying, is to change to improper fractions. So 12 times 2 is 24, plus the 1 is 25. So I have 25 over 2 now, divided by 2 times 2 is 4, plus the 1 is 5. So I now have 5 over 2. Next, we're going to go ahead and do that keep it, change it, flip it rule. So 25 over 2 times 5 over 2 changes to 2 over 5. And now we can cross reduce. And in this case, we can cross reduce both ways. So 25 and 5, I can divide this by 5 and this by 5. And then this by 2 and this by 2. So 25 divided by 5 is going to be 5. 2 divided by 2 is equal to 1, times 2 divided by 2 is 1, and 5 divided by 5 is 1. Then we can do 5 times 1, which is 5, 1 times 1, which is 1, and then this actually is just a simple division problem. 5 divided by 1 is equal to 5. So what this tells us is that we can make 5 shelves out of the 12.5 feet of wood in that board. That's what we can do. Okay, so that is our final question for this presentation. So to recap, our learning objectives for this presentation were to multiply and divide mixed fractions, mixed numbers. We then also learned how to simplify complex fractions, simplify expressions written with the fraction bar, and then also some word problems. So we went back to that first original objective, multiplying and dividing mixed numbers with some word problem context. So I go ahead and go to the OpenStax textbook now. You can find the link in the description below. Do a few more problems. If you do have any follow-up questions, feel free to put it in the comments of the video. Good luck, everyone, and I'll see you in the next video.